Components of a vector. Before you work through this video, you will need to know how to add vectors using the tail-to-head method. If necessary, you should refer to the following video, which covers this topic. In some situations, resolving the addition of vectors using the tail-to-head method that we saw in the previous video is difficult. For instance, when we sum two vectors that are not in the same direction, or when the addition of two vectors do not lead to the formation of a right triangle. Because of this, we will learn how to add vectors by components. Thanks for watching this video, and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. In the discussion of vector addition in the previous video, we saw that two vectors acting together can be combined to give a single vector, the resultant. Just as two vectors can be added to give a resultant vector can be broken down into two vectors which, when added together, make the resultant vector. Those vectors whose sum gives the resultant vector are called components on the resultant vector. The process of finding the components of a vector is called resolving the vector. The word components in the following context means parts. So, to talk about the components of a vector, we mean the parts of a vector. Typically, a physics problem gives us an angle and a magnitude to define a vector. So, we have to find the components ourselves using a little trigonometry. Suppose we have a vector that is at an angle theta to the horizontal. So, let's resolve the vector. In other words, let's find the components of the vector. It's very useful to draw vectors on the Cartesian plane, as we will see as follows. From the tip of the vector, draw lines parallel to the axis and mark the point on each axis where the lines intersect the axis. The vector A was broken into its components, the vertical component and the horizontal component. If you draw a vector along the x-axis from the origin to where the blue line intersects the x-axis, then this vector is the x component of the vector A. If we draw a vector from the head of the vector A sub x to the head of the vector A, then this vector is the y component of the vector A. The components a sub x and a sub y are the components of the vector A. The components form the legs of a right triangle, with the original vector being the hypotenuse. Now we can use trigonometry to calculate the magnitudes of the components of the vector A. To find the size of the x component, we have to find the length of the adjacent side. What trigonometry function relates the hypotenuse and acute angle and its adjacent side in a right triangle? The cosine function does. By multiplying both sides by a, we can express the horizontal component of the vector A as a times cosine of theta. To find the size of the y component, we have to find the length of the opposite side. What trigonometry function relates the hypotenuse and acute angle and its opposite side in a right triangle? The sine function does. By multiplying both sides by a, we can express the vertical component of the vector A as a times sine of theta. Calculate the components of the following vectors. The vector f has a magnitude of 10 units and it makes an angle of 30 degrees with the x-axis. Always start by drawing the components, because if you forget the equations, you can always retrieve them from basic trigonometry. In fact, no need to memorize these equations. To find the x component, replace f by 10 and theta by 30 degrees. Use your calculator to get the cosine of 30 degrees and perform the calculations. To find the y component, replace f by 10 and theta by 30 degrees. Use your calculator to get the sine of 30 degrees and perform the calculations. The vector t has a magnitude of 7 units and it makes an angle of 60 degrees with the x-axis. Always start by drawing the components and take the equations. To find the x component, replace t with 7 and theta with 60 degrees. Use your calculator to get the cosine of 60 degrees. The x component is along negative x-axis, so a minus sign has been put in by hand. To find the y component, replace t with 7 and theta by 60 degrees. Use your calculator to get the sine of 60 degrees and perform the calculations. The vector s has a magnitude of 5 units and it makes an angle of 35 degrees with the x-axis. Always start by drawing the components and take the equations. To find the x component, replace s with 5 and theta with 35 degrees. Use your calculator to get the cosine of 35 degrees and perform the calculations. To find the y component, replace s with 5 and theta by 35 degrees. Use your calculator to get the sine of 35 degrees. Both components are along the negative axis, so a minus sign has been put in by hand. There are a number of ways that vectors can be represented. One of these representations involves expressing a vector in terms of their components. Look at the vector A. We can write the vector A in component form by adding the horizontal and vertical components. We can write a vector in component form using unit vectors as well. A unit vector is a vector that has a magnitude of exactly 1 and points in a particular direction. The symbol is usually a lowercase letter with a hat, such as. The x with a hat means unit vector in x direction, and y with a hat means unit vector in y direction. Do not forget that the magnitude of vector A is given by Pythagoras' theorem. Now we are going to write the vectors f, t, and s in component form. The vector f is equal to 8.7 units in x direction plus 5 units in y direction. The vector t is equal to minus 3.5 units in x direction plus 6.09 units in y direction. The vector s is equal to minus 4.1 units in x direction plus minus 2.87 units in y direction. A much more efficient method of adding or subtracting vectors used in physics and mathematics involves using component vectors. Now that you know how to break down vectors in their components, you will learn how to add or subtract vectors by components. Suppose we want to add up two vectors to find the resultant vector, such as the vectors v and t. First, we must break down each individual vector into its components. Pay attention. Write each of the vectors in component form. Add up all component vectors that lie along the x-axis to get the x component of the resultant vector. Next, add up all components vector that lie along the y-axis to get the y component of the resultant vector. Now that we have the components of the resultant vector, we can use Pythagoras theorem to determine its magnitude, and we can use the tangent to get its direction. Pay attention. Let us draw a diagram that shows this result.